Okay guys, today we're going to be starting our unit on graphing linear equations. We're going to be breaking it apart into graphing lines using x and y intercepts, graphing lines in slope-intercept form, graphing lines in point-slope form, and standard form. So 4 different ways of writing a line. We're going to start today with x and y intercepts. But before we do that, since this whole unit is focusing on linear functions, I want you to take a look at these descriptions in our box at the top and circle the functions that you think are linear functions. So you'll see a graph, example of 2 graphs, some tables, and then some equations. Pause the screen and take a second to decide which of those you think is linear. And then I want you to think in your head what it does mean to be linear. If we check these out, the first line we have here is a straight line. The second one is what we call a parabola, kind of curves. The one that you should have found to be linear is the one on the left. Obviously, and when you see this word linear, you see the word line within it. First thing that you should think of, or one of the things you should think of when you think of a linear function, it needs to be a straight line. In our next table, hopefully you recognize some rates of change. So on this left table, try to find what each of the x values are increasing by. They're each increasing by 1 each time. Corresponding with that, on the right side, they're also increasing by 1, keeping that pattern consistent. On the right side, if we look at those, these are changing by 1. On the right side, they are not so consistent. The one on the left is our example of a linear function. A linear function must have a constant rate of change. And last but not least, let's check out our equations down below. The linear functions, well, there was only one of them. Y equals 3x minus 17. You might be wondering why these guys are not linear. You might not even know what they look like when you graph them. You can always use your graphing calculator to see what those graphs would look like. But let's go over how you can tell from an equation that something is a linear function. First of all, x and y must have an exponent of 1. Going along with that, what that means is you cannot have x or y under a radical or in the denominator. Those would make non-linear functions. So key idea, if you're looking at an equation, the x and y need to have an exponent of 1 or to the first power. That is what it means to be linear. Let's take a look at our new vocabulary words today, or the ones we're going to be focusing on, which are x and y intercepts. In our last unit, you were introduced to x and y intercepts, so I want y'all to take a second and fill in the definitions for what is an x-intercept and what is a y-intercept. Fill those out on your own. An x-intercept is where the function crosses the x-axis. X-intercept crosses the x-axis. It occurs, of course, whenever you cross the x-axis. And I want y'all to remember what the y value equals at this point. So you have the x value. Anywhere along that x-axis, your y value is going to equal 0. So it occurs when y equals 0. Or when f of x equals 0. Remember, f of x and f of x and y are synonymous to each other. So using that information, if you're given an equation and want to find the x-intercept, you set the y value equal to 0 and solve for x. That's how you would find it if you were given an equation. If you were given a graph, you can simply look and see where the graph crosses the x-intercept. So the x-axis. So like if you were looking at a graph like that, you would of course look and see, oh, here's our x-intercept. We will be using both of these, setting y equal to 0, solving for x, and then also finding x-intercepts from graphs. Let's go over to y-intercepts. Very similar, except now we're talking about the y-axis. So it is where the graph crosses the y-axis. So think about if you have a y-intercept crossing the y-axis. The y value is obviously the y-intercept. Our x value is 0. So it occurs when x equals 0. So using that knowledge, if you were given an equation, not given a graph, if you were just given an equation and you wanted to be able to find your y-intercept, you would set x equal to 0 and solve for y. If you were given a graph and you wanted to find the y-intercept, you would simply find where the graph crosses the y-axis. Let's flip it over to the back side of our notes and find x and y intercepts from equations. We're going to practice using the steps for how to find the x and y intercepts algebraically. Go ahead and turn the page over. So you'll see a few examples up at the top. We're going to zoom in on number 1, and the first thing we're going to find is the x-intercept. Remember, to find the x-intercept, you're finding where the graph crosses the x-axis. So remind yourself, what is that y value at that point? It is 0. So to find the x-intercept, you set y equal to 0 in that equation up above. So we're going to plug in 0 for y. In that case, we would have 18 times 0 equals 12x plus 108. We would now solve for x. Well, what does 18 times 0 equal? 0. Now continue solving for x. We get -9 as our x value. Make sure to write that as an ordered pair. The x-intercept would occur at -9, 0. Box your answer. Let's do the same thing for the y-intercept. Remember, for the y-intercept, similar process, except now you're going to set x equal to 0. Because if you're finding the y-intercept, the x value on that y-axis is always going to be 0. So you're plugging in 0 for x. So go back to your equation up at the top, 18y equals 12x plus 108, and in place of x, we're putting a 0. So we have 18y equals 12 times 0 plus 108. Simplify. What is 12 times 0? Well, 0. So we only have 108 on the right side. Divide by 18. You should get y equals 6. Please make sure that you're writing that as an ordered pair and not just leaving it like that. So your x value you plugged in was 0. Your y value you got out was 6. Cool. Let's try it again on the next one. On example 2, let's start out by finding the x-intercept. Remember, to find the x-intercept, you make the opposing variable y equal to 0. So plug in 0 for y. And solve for x. It's okay to get a fraction. You can just leave it as an improper fraction. What I do care about is that you write it as an ordered pair. So our x value is 4/3. What is our y value? 0. Box that answer. Do the same thing. Now find your y-intercept. We're going to set x equal to 0. So you should get y equals -4. Just write your answer as an ordered pair. Pause and rewatch if that was confusing. Last one we're gonna look at is example number 3. This equation here is what we call it's in standard form. When it's in standard form, the cover-up method is kind of nice to use for finding your x and your y intercept. Cover-up method just makes it really easy to write an equation quickly. So x-intercept, we're going to set y equal to 0. If we set this y value right here equal to 0, imagine what happens to this whole term. It just cancels out. It's gone. So we're just left with 6x equals 1. You can kind of skip a step. You don't have to plug in that 0. So we get x is 1/6. Write it as an ordered pair. Similarly, let's try it for the y-intercept. Remember, to find the y-intercept, we set x equal to 0. So go back up to your equation. If you plug in 0 for that x value, that whole second term is going to be gone. So you're just going to be left with -2y equals 1. Solve for y to get -1/2. Box both your answers. Let's now try it with graphing. By the way, when you're using x and y intercepts to graph an equation, it's helpful because when you say x and y intercepts, how many points are we finding? We're finding 2 points. So you find 2 points, and if you have 2 points, you have enough to make a line, so you can just connect them with a straight line. That's all you need to know to graph your line. So let's try it out with example number 1. Pause the screen and find your x and your y intercept. Check yourself. You should have gotten that your x-intercept was -4, your y-intercept was 8. We can fill it in this table down here. The x-intercept was -4, making our ordered pair -4, 0. Our y-intercept was 8, making our y value 8, and our x value 0. So we're going to take these 2 points, put them on the graph. X-intercept, -4, put a point. Y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. Make a point. Folks, you have 2 points. You know it's a linear function. Your x and y values have an exponent of 1. You can just connect them. And you've got yourself your lovely linear function. Y equals 2x plus 8. Let's go over here and try the right one. Pause the screen, find your x and y intercepts. All right, check yourself here. You should have found that your x-intercept was 2. So you can plug it into your table as 2, 0. And your y-intercept you should have gotten was -8. So make sure when you plugged in that 0 for x, you have 0 minus y. That -y is not isolated yet. You needed to divide by -1 down here. So that's where I got that -8. Now you have 2 points. Go ahead and put them on the coordinate plane. Your x-axis should have a point at 2, 0. Your y-axis should have a point at -8. It's a linear function, so you can just connect those 2 points, and voila. Last one I want you to try on your own is example number 3. Sorry about this typo here. Ignore that. That's supposed to go with this. Try out, let's actually do number 4. Try to work through the entire problem on number 4, graphing, finding your x-intercept algebraically and y-intercept algebraically, and I'm going to pause the screen and we'll check ourselves in a minute. All right, folks, let's check out your work here. You should have found that the x-intercept was 5. Remember, you find that by the x-intercept by setting the opposing variable y equal to 0, which I did in this step. You then came up with this equation. I added 4x to the other side, divided by 4. 20 divided by 4 is 5. You write that as an ordered pair, 5, 0, and it's plotted on the graph right there. Your y-intercept, on the other hand, you set the x equal to 0. So I plugged in 0 for x. You get 20 equals 5y. Divide by 5, the number in front of y. You get y equals 4. Make sure to write that as an ordered pair. It goes on your y-axis up at the top. You got your linear function. We're going to take it one more step and try out a word problem down below. All right, in this word problem, they tell us, the student council wants to raise $360 for the 8th grade dance. Let's maybe highlight that. That's probably important information. Trying to raise some money, they want to make $360. They're going to sell t-shirts and sweatshirts. So they're selling two things, t-shirts and sweatshirts. Other important information. They tell us that they get $4 from each t-shirt and $6 from each sweatshirt. Let X represent the number of t-shirts and let Y represent the number of sweatshirts. So they're selling two things. We don't know how many of each they need, t-shirts and sweatshirts, but they want to make how much money? Well, we know that they need $360. That's going to come from t-shirt sales and sweatshirt sales. They get $4 from each t-shirt, $6 from each sweatshirt. But should we just add 4 plus 6? Of course not, because they're not just going to sell one t-shirt. Do we know how many t-shirts they're going to sell? X, we don't know. Do we know how many sweatshirts? Y, they tell us, is what the sweatshirt should stand for, so we don't know. We've now got ourselves an equation. We're going to start out by finding the X and Y intercept, because eventually we are going to graph what this function will look like to help us find out how much of each type the student council can buy or sell, to make their $360. Remember from the problems that we've done before, if we want to find the x-intercept, you set y equal to 0. If we set y equal to 0 right here, 6 times 0 would give us 0. So we're just left with 4x equals 360. Go ahead and divide that out. 4 goes into 36 9 times, add a 0 on. Make sure you're writing that as an ordered pair, 90, 0. Similarly, let's find the y-intercept. Set the opposing variable equal to 0. If you plugged in 0 for x here, 4 times 0 would give you 0, so we're just left with 6y equals 360. Go ahead and divide by 6. 6 goes into 36 6 times, tack on another 0, and you've got yourself the ordered pair 0, 60. Now, this is a contextual problem. These points actually mean something. So let's go back and look at the point 90, 0. Remember, in the X spot, the X, they tell us, stands for the number of t-shirts. So that tells us if they sold 90 t-shirts and 0 sweatshirts, they would make $360. If they sell 90 tees and 0 sweatshirts, they'll hit their target. They will make $360. Use that same kind of context to figure out what this y-intercept means. 0, 60. Remember that the y represents the number of sweatshirts that they're selling. What that is telling us is if they sold 60 sweatshirts and 0 t-shirts, they would still make their goal of making $360. So if they sell 60 sweatshirts and 0 tees, they will still make their goal of $360. Now, obviously, these are extremes, right? You're selling all of one thing and nothing of another, which is unlikely to happen. So we're going to graph the line, and all the points on the line are going to tell us different ordered pairs, different combinations of t-shirts and sweatshirts that they could sell. So you'll see on the graph below, it's labeled t-shirts and sweatshirts. Let's go ahead and put our x-intercept on there, 90 tees, 0 sweatshirts, and then our y-intercept, 0, 60. And then we have 2 points on that line, so we can connect them. Anything on the line represents a combination that will earn exactly 360. So this is kind of hard for me to see because I don't have tick marks on my graph. But like 30, 45 looks like it's pretty close. I guess I could plug in. But any point that is exactly on that line will give you a combination of things that will equal exactly 360. Now, what if they wanted to earn more than 360? Where would those combinations be? Those would be anywhere above the line. So anything in this region would give them money that is above their goal. So for example, if they sold, let's say 40 t-shirts and 75 sweatshirts, that would put them in the pink region above the line. They would make more than $360. Anything below the line, on the other hand, anything down here, guess what, guys? That means they're not meeting their goal. So for example, if they sold 5 t-shirts and 30 sweatshirts, they would not make $360. So this would earn less than $360. The graph is especially helpful if you're like planning a business plan for something like this. It could be very useful in a real world situation. You're going to try out some problems like these on your homework. Come back to the notes if you have questions.